I'll give questions. We'll solve the questions from real numbers, and in the next class, we'll start with a new topic.
Okay, sir.
Just a minute, let me share the screen. So, are you all finishing the homework, guys? Every day I'm giving the homework. So, are you all doing that sincerely? I'm asking you guys.
Yes, sir.
Sir, actually, I don't know, sir. Where does the homework be available?
Who's that?
So, Sai Charan, sir.
Yes, Charan, what's the problem?
Sir, I don't know, sir. Where is the
You don't
homework?
know? You don't know what you don't know.
Sir, where is the homework available, sir?
I told the homework, I think you're not watching recording videos then. I told you that the homework problems are in a Vice app. I'll show you. Look at this here. I'm just giving you homework every day. If you can you see the screen here? Can you see the left side overview, discussions, test,
Yes, sir.
resources, assessments? If you go through the resources, you can find out quadratic equations questions here. Can you see this?
Yes, sir.
Yes. That is what the worksheet I have given to you all. Please go through that, find it up. All right. Okay, and start solving the questions and come up with your doubts. So coming to today's class, I'll be giving you the questions. We'll go with that.
Okay, sir.
Yes. 1 second. One second. Yes. Look at the questions. Can you hear me now? 1 second. I think there is a voice. Now can you hear me, guys?
Yes, sir.
Yes. Take the question. We were solving few questions, so I'll give you a few more questions today. Guys, show that the square of any positive integer cannot be of the form 3m plus 2, where m is a natural number. How can you prove this? By using Euclid's division lemma method. Guys, only 2 minutes of time. Everyone should try to solve that. And if at all you get any idea, and tell me, sir, this is how we can solve this.
Sir, what is ST?
Sorry,
What is S and T?
what is F? I didn't get you.
S and T, sir. ST.
That is positive. You're not, look at this here, positive. That is what I'm asking everyone to listen the class properly. I'm ready. This is positive integer. I wrote in a short way. Positive integer, beta. Clear? Is it clear?
Yeah, sir.
Yes. Show that. Akshara, that is show that. Show
Okay,
that.
sir.
We have to show that. Pos. Yes. Show that the square of any positive integer cannot be the form of 3m plus 2, where m is a natural number. Look at this, guys. This prove that questions are a bit challenging questions. How many have you done? How many have you got an idea? I'll tell you how to solve this question. Look at this here. First of all, as per the question, what he has given, any positive integer, let's take. He has given a positive integer. Let's take any positive integer here. Okay. So as per the Euclid's division lemma, what is the formula we had? A is equal to BQ plus R. Correct?
BQ plus R.
So here he has given, look at this here, B, Q plus R format, right? So what is the B value he has taken as per the question? According to the question, B is equal to 3. Okay. So A is equal, so let's take like this, right? BQ. So I mean 3M plus 2 given, which is nothing but 3M plus R. Can I write 3M plus R? What is R here? As per the question, 3M plus R means R is 2. Correct? So what can be the R value now? What can be the R value? So R can be 0, 1, 2. If R is 0, what is A value? 3M. If R is 1, what is A value? 3M plus 1. R is 2. 3M. Very good. Very simple. Now, first suppose if I take A value, this one, this one, this one. Now, let's take A values and substitute. If A value 3M, then A square is going to be what? 9M square. Correct? All right. So A square can be written as what? 3 into 3M square. Do you agree with my point? Now A square is equal to 3 into 3M square can be written as what? Anything you take. So
Sir, can you repeat again? Sir, I didn't understand.
which one you didn't understand?
Sir, why did we multiply 3 into 3M square?
Look at this. What he has given in the question. Read the question. You didn't read the question. Square of any positive integer. Square. Getting my point?
Yes,
Yes,
sir.
Square of any positive integer he has given. So I'm taking the square. Correct? So A square is equal to 9M square. So 9. So here now A square is equal to 3Q. I can write in bracket. You can write 3M square is equal to Q. Correct? 3M square is equal to Q. So now this is the case. Now if A is equal to 3M plus 1, that is what we had checked. If A is equal to 3M plus 1, what is A square is going to be? A square is nothing but A square plus B square plus 2AB. So A square is equal to 3 taking common, 3M square plus 2M. The remainder is 1 as it is I'm writing. So what is Q is equal to here? A square is equal to 3 times of Q. So where Q is equal to, you take where Q is equal to 3M square plus 2M. Correct? Now let's take another case. If A value is 3M plus 2, this is a standard and common procedure beta. Okay, everywhere we have to solve. Look at this here. Everywhere we have to move follow the same method. A square plus B square plus 4. So 12M. So A square is equal to 3 taking common. So 3M square plus 4M plus 4, let's write as 3 plus 1. Correct? So let's write A square is equal to 9M square plus 12M 3 plus 1. If I take 3 common, plus 1 and plus 1 here remains. So here A square is equal to 3Q, and where Q is equal to what? 3M square plus 4m plus 1.
4m plus 1.
Correct? Yes, Pranav, tell
Yes,
me.
sir.
So you could also take 3m common, right? Why didn't you take 3m common?
Where?
You could take 3m common, right?
Yes,
So
look at
instead,
yeah, I understand your point. See here, in terms of what is that? See, in terms of getting a common thing everywhere. So a square, look at this here, what I am getting. A square is equal to 3q, a square is equal to 3q, a square is equal to 3q. For maintaining that, I couldn't take the a 3m common here. So now from this, what we get to know? From this, what we get to know actually? So square of, look at this here, square of any positive integer cannot be of the form 3q plus 2. Check. That is my question. Look at this. What is the question here? Square of any positive integer cannot be of the form 3m plus 2. Where 3m plus 2, so where m is a natural number. So now check here. What is your name? Pranav, you are asking, right? The reason behind not taking 3m common is square of any positive integer cannot be of the form 3m plus 2, where m is a natural number he has given. So we have to square that particular m. You cannot take m common. So let it be as a common part. Look at this. All right. So don't take common. Why? Because we are squaring that and checking whether it is coming other than natural number or not. Yes. Look at this here. What we understood
sir.
from this? What we understood from this? Square of any positive integer. Square of any positive integer. Check. Square of any positive integer. Square of any positive integer cannot be of the form 3q plus 2. Are you getting anywhere 3q plus 2?
No,
Are
sir.
you getting anywhere? Getting? Are you
Sir,
guys?
in second and third one, we'll get 3q plus 1 more, sir.
Yes, sir.
Yes.
3q plus 1.
3q plus 1 here. I'm sorry. 3q plus 1 I didn't write. Yeah. 3q plus 1 we forgot to write. So look at this. 3q plus 1, 3q plus. Are you getting anywhere 3q plus 2? Check. Is there anything that you are getting 3q plus 2? Boys and girls, are you getting anywhere? I'm asking you only. No, square. Look at a square. I took a. What was my? Look at this here. I took. If any positive integer I took a beta. Square of this. Square of this. Are you getting anywhere something like 3q plus 2 or 3m plus 2?
No, sir.
Of the form he is saying. So it can be 3q plus 2 or you can say 3m plus 2. Any letter you can write it, Babu, no problem. Okay. Are you getting anywhere these type of forms in the results?
No,
Are you
sir.
getting anywhere? No, we are not getting. Check. If you want, you can check. So that is how we can prove. This is the best proof. This is the best way to prove. This is the best way to prove. Look at this here. Nowhere we are getting 3q here, 3q plus 1 here, 3q plus 1 here, but nowhere we are getting 3q plus 2, something like this. Nowhere we got. So hence proved, you can say that, look at this now. Therefore, square of any integer
So after writing the constant, scroll up, sir.
can't be of the form 3q plus 2 and where q is equal to natural number. That is what he has given. Yes, tell me, Harini.
So once can you scroll up, sir? Got it, sir.
See here, many of you might be getting. Can anyone of you explain me why did we take R value 0, 1, 2? I'm checking the possibilities. Let's take 0, whether we get or not. Let's take 1 and let's check whether we get or not. Let's take
Because the remainder should be less than, more than or equal to 0 and less than the divisor.
Yes, sir.
Reminder.
Should be more than or equal to 0 and less.
I can't hear you properly. More than.
So the remainder should be more than or equal to 0 or and less than b.
Yes, less than the value given to you. Less than the value. What is the value given? 3, right? Yes. What is the d? What is b? What is b here? What is B here?
So 3, sir, 3.
What is the name of what is the name of the B? How do you indicate that? What is
Sir, is it? It is the divisor, sir.
yes, it's the divisor. It should be greater than and less than 0. So less than what is the divisor? That is the reason 0, 1, 2 I took. Possibilities I'm taking R value 0, R value 1, R value 2. I'm taking possibilities, and I just wrote these 3 cases. Every case I'm in each and every case I'm not getting 3q plus 2 format. Nowhere I got this form, so that is my proof, I could say happily. Next, shall we go for another question? Guys, all of the most of the questions you will be finding show that square of the integer can be of the form. Next, shall I give one more question? Will you be able to try now? So that the square of an odd integer can be of the form. Take 2 minutes, make it fast. I should see everyone responding in the class and everyone participating actively in the class. Those who do not know, please drop a message that I do not know. Everyone must engage in the class. Yes, what happened, guys? Any one of you got the answer? Any one of you tried? Any idea you can share?
Right.
See what he has given here. Show that the square of an odd integer can be of the form this one or this one for some integer q. So first of all, we'll go with let's take two numbers, a and b. A and b. I'm taking a as odd integer and b is equal to, so 6q plus he has given, right? So b is equal to what is 6, isn't it? Am I correct?
Yes.
Yes.
Yes, sir.
Good. Now a is equal, as per the Euclid's division lemma, what is that concept? A is equal to bq plus r. That is the formula. So now
So
can
I
I write
sent
this?
you an answer right now.
You sent the answer. Okay. Yes. Okay. We'll see that. Good. For some integer, look at this, what he has taken. A is equal to odd, b is equal to 6. Now a is equal to, look at this here. If you observe this, 6 b value given, q plus r. So here for some integer, q must be greater than or equal to 0. So what is r is going to be now? 0, 1, 2, 3, 4, 5. Correct? Why? Because since you write here, since r must lies between 0 to 6, it should be less than or equal to 0 and less than 6. So what we have here now, a value is what now? 6q plus 0. A could be 6q plus 1. A could be 6q plus 2. And similarly, 6q plus 3. A is equal to 6q plus 4. A value is 6q plus 5. Correct? Isn't it? All right. Any doubts?
No, sir.
So what we need to choose here? We need to choose odd, right? So let's choose this one, and this one. Isn't it, beta? We are choosing these three. Why? Because they are having odd. So for suppose for a value called 6q plus 1. So what is a square is going to be? What he is talking about? Square of an odd integer. So let's do square. A square is equal to 36q square plus 1 square plus 12q. Am I correct? A square is equal to, so what can you take common? 6 common. 6q square plus 2q plus 1. So here a square is equal to 6. Let's write this is something k plus 1, and where k is equal to what, beta? Okay, this is one case I took. All right. Let's take another case. For a value 6q plus 3, a square is equal to 36q square, a square plus b square plus 2ab. 2ab is nothing but 36q plus 9. A square is equal to 36 common. Shall we take 36 common? No, let's take 6 only common. 6q square plus 6q plus, this can be written as what?
Plus 1.
No. 6 plus 3. I'm taking 6 common, so 9 can be written as 6 plus 3. So here 1 plus 3. Correct? Where, let's write the form like this. A square is equal to 6k plus 3, where k is equal to 6q square 6q plus 1. Correct?
Yes, sir.
Next, for a value 6 cube plus 5, a square is equal to same procedure beta, there is no change at all. Okay, so how much here? 60, right? 60 cube plus b square is which is 25. So a square is equal to 36 q square, 60 cube. Let's take 4, 24 plus 1. Let's say 24 plus 1. So if I take 6 common, 6q square, 10q and 4 plus 1. So a square is equal to 6k plus 1, where k is equal to 6q square plus 10q plus 4. Check. All right. Look at this. What is the question here? What is the question? Show that square of an odd integer can be of the form 6q plus 1 or 6q plus 3 for some integer q. Check. Are we getting the forms something like that? 6q plus 1. Look at it. This is looking like square of odd integer.
Yes,
Either
sir.
this form, look at this, or this form. But sir, why we are not getting 6q plus 3, right? Why did you write we got 6k plus 3? Beta, here k, q, a, b, anything you take, that form, in the form of, isn't it looking like 6q plus 3? Isn't it? So what we have to prove here, a square is equal to, sorry, here 6q plus 1. So either 6q plus 1 or 6q plus 3 form we will be getting everywhere. When, if you do square of an odd number, square and odd positive integer. Look at this. Square of odd integer can be of the form 6q plus 1 or 6q plus 3 for some integer q. Understood my point? Is it clear with everyone? Any doubts? Is there any doubts?
No, sir.
Very simple. No. Will you be able to solve if I give another type of question?
Yes, sir.
Yes, I'll give a question, something like one last question will solve this type of question. I mean, show that questions. Next, we'll go for next type of question. Show that. One and only one out of n comma n plus 4 comma n plus 8 comma n plus 12 and n plus 16 is divisible by 5, where n is any positive integer. Okay, show that one and only one out of n plus 4, n plus 8, n plus 12 and n plus 16 is divisible by 5, where n is any positive integer. Try to read the question. Think what is the form he has given.
Okay, sir.
So divisible by 5 is nothing but what is the divisor here? Divisible by 5 given. So what is the divisor? 5, isn't it? Am I correct? According to Euclid's division lemma, any positive integer, let's take any positive integer, let n and b is what? B is equal to 5. Why? Because yes, given divisor something, I mean divisible by 5. So any positive integer n, b, q plus remainder. So what is your q here? Quotient. B is divisor. N is any positive integer. Dividend, I mean R is remainder, correct? What is R lies between now? What is R lies between here? R lies between where to where?
Lies between 0 and 5, sir.
Exactly. So now, so what is R values are going to be? 0, 1, 2, 3, 4. Correct? Isn't it? So what is the N value is going to be then? Then what is N value is going to be? B value is 5, right? So 5Q and 5Q plus 0. You can write it as 5Q plus 1. N value can be 5Q plus 2. Yeah, let's write here N value 5Q plus 3. N value can be 5Q plus 4. N value can be 5Q plus 5. Correct? Isn't it? Sorry, 5Q plus 5. No, you have just only this 4, 5. Correct? Yes. So let's go with case 1, case 2, case 3, case 4, case 5. Look at this. How many cases we have here? Total 5 questions, 5 cases you could see here. One by one we'll go. So let's go with this one. First of all, let's solve n is equal to 5q. Correct? What is n here? 5q, right? So what is my requirement? Show that out of this and this is divisible by 5. Divisible by 5. So look at this here. Let's see. He has given some n. So let adding 4 on both sides. If I add 4 on both sides, what happens? This is what happens. Okay, adding 4 again. What happens now? N plus 8, 5q plus 8. Adding 4 again. N plus 12, 5q plus 12. Adding 4 again, n plus 16, 5q plus 16. Now check whether n is divisible by 5 or not now. Guys, why we are adding 4, 4, 4? Tell me here. If you observe the pattern he has given to you, look at this here. 4. Oh my goodness. 4, 8, 12, 16, n plus 16. So I'm checking with each and every case.
Yes, sir.
Whether you are getting or not, guys. I'm asking, look at this here.
Yes, sir, got it.
Adding 4 on both sides, adding 8 on both sides, adding 12 on both sides, adding 16 on both sides. Okay. You write adding in bracket. Adding 8 on both sides, adding 12 on both sides, adding 16 on both sides. Correct? So this is what I got. Now tell me here. Now can you see what I here? Here n is divisible by 5 or not here? Is this possible? Here n is divisible by 5 or not? Yes. You can say n is divisible. N is only divisible by 5 here now. N is divisible by 5. Now, if you similarly take the case 2, n value was 5q plus 1. Now adding 4, 4 on both sides again and again. Look at this here. So n plus 4, 5q plus 4 plus 1, 5. Can I write directly like this? If you want me to write like this.
Yes, sir.
Now adding 4 again, adding 8 on both sides, adding 8 on both sides. So 5q plus what? 8. 8. So 8 plus 1, 9. Isn't it? Guys,
Yes,
adding
sir.
4 on both sides, I got this.
Yes,
Adding
sir.
8 on both sides. Now adding 12 on both sides.
13. 5q plus 13.
N plus 16. 16 on both sides, so 17 here. Correct? So now look at this here. Check which is here n plus 4 is divisible by 5 or not?
Yes, sir.
No, n plus 4 is divisible by 5. Yes, very good. N plus 8, check.
No, sir.
Why?
Because we cannot write it in the form 5Q.
I didn't get you.
Sir, we cannot write it in 5.
We cannot.
We cannot write it in the form 5Q, sir.
Yes, 5Q plus 1. Isn't it? So n plus 4 is only divisible by 5. Rest. This one, is it divisible by 5? Is it divisible by 5 or not? Check.
No,
Guys,
sir.
n plus 4 is only divisible by 5. I'm asking why these are not divisible by 5. Anyone of you?
Sir, because if we take common, we'll get remainder, sir.
Exactly. I have been telling the same. No one is catching. Very good. What is your name, beta?
Saranya.
Saranya ji. Very good. Look at this here. What can you take common here? 5Q plus 5 plus 4. 5Q, if I take 5 common, Q plus 1 plus 4. 1 second, guys. Be in line. Yeah, Dipshika, you was in the waiting list, right?
Yes, sir.
See, if at all anyone who is waiting in the waiting room, who are in the waiting room, please kindly drop a message me in a WhatsApp immediately. Sir, I'm in the waiting room. Can you please admit me? Okay. Is it clear?
Yes, sir.
Yes.
Okay, sir.
So, guys, look at this here. Here, n is divisible by 5, I said. Why? Because here remainder is 0. All right. Here only n is divisible by 0. Here also look at this here. N plus 4 only divisible by 5. Why? Because remainder would be 0. Am I correct? If here remainder is left, you left with remainder. Here you left with remainder. Here you will be left with some remainder. So these all are not divisible by 5. Which are these are not divisible by 5. Not. Guys, are you understanding or simply remembering? Don't remember here. Think. सोचना पड़ेगा. Not divisible by 5. This is divisible by 5 here. Correct? Understood my point?
Sir, could you explain the whole thing once?
See, beta, here, what I'm trying to say, here, n 5q plus 5 I have, correct? 5q plus 5 I have, am I correct?
Yes.
That is divisible by 5. This is divisible by, sorry, this is divisible by n plus 4. Why? Because, sorry, n plus 4 is divisible by 5 here. N plus 4 is only divisible by 5. 5. Why? Because look at this here. If I divide with the 5, what happens? Remainder you are getting 0 or not? Look at it, n plus 4 as it is. I'm writing. If I take 5 common, beta, q plus 1 plus 0. Your remainder is 0 or not here? Understood my point? Hello?
Yes, sir.
When can
Yes,
you say divisible by 5? Whenever the remainder is 0. Now look at this here. I'll check. I'll give a simple example. 4. I'm dividing with the 2. When can you say, not 4? You take simple understanding purpose. Dividing 10 with the 5. 5 to 10. When the remainder is 0, then only I can say 10 is divisible by 5, isn't it? 10 can be written as what here? 10 can be written as 5 into 2 plus 0. Isn't it looking like A is equal to BQ plus R? B is divisor, Q is quotient, R is remainder, A is dividend. That is what happening here. Isn't it, beta? Any doubts
Yes.
now? Is it clear?
No doubt, sir.
Very simple. So here, that is what happened. Now, if you take all these cases, beta, if you take here, what is the remainder? You left with 4 remainder. You left with what here? 9 remainder. You left with what here? Some other remainder. So all these are not divisible by 5. So only n plus 4 is divisible by 5. Here what? Here n is only divisible by 5. N is only divisible by 5. Why? Because n is only divisible by 5. Why? Because remainder would be 0 there. Am I correct? Any doubt here? Hope it is clear now.
No, sir.
Now, if you go with another question, beta, look at this here. Which one? You take another case. So I took this case as well. Now take this case, take this case, take this case. What we have to do? We have to show that. We have to show that. All right. Is it clear or not, people?
Yes, sir. Clear.
Will you be able to solve now very easily? It looks very big. It looks very big. For writing, it might take several steps. But understanding is very simple. बच्चों का calculation. Isn't it? Am I correct? Hello, people.
Yes, sir.
If you take case 3, if you take case 3 here, let me write, let me erase this beta, or else let me keep this side aside. Okay, case 3, n value 5q plus x to 5q plus only. Yes. So what I have to do now? Adding 4 on both sides. 5q plus 6. Adding 8 on both sides. 5q plus 10. Adding 12 on both sides. 5q plus 14. N plus 16 on both sides. So 5q plus 18. Now which is divisible by 5? Tell me now. Which is divisible by 5? Which is very simple.
+8.
N plus 8. Very good. Look at this. Whether what is the remainder here? Look at all this tape. All these people will not go in 5 table exactly. You will be left with some remainder. But for 10, you will not be remainder. For 10, you will not be getting any remainder. Your remainder would be 0. So only this will be divisible. Okay. So what can you write now? N plus 8 is only divisible by 5. Correct? How? If you want to check, you can check. Isn't it better? Look at this 5 common. 5q plus 2 plus 0. Remainder is 0 or not? 5q plus 10 I am getting, remainder is 0. So only n plus 8 is divisible by 5. All right. Now fourth one, n value 5q plus, fourth case, nq plus what beta? Nq plus 3. Nq plus 3. So check in adding 4 on both sides. N plus 4, 5q plus 7. This is not divisible by 5. All right. Adding 8 on both sides. 5q plus 11. Not possible. Adding 12. Yes. 3 plus 12, 15. It is divisible by 5. N plus 16. 5q plus 19. Not possible. So which is divisible by now? N plus.
Sir, even 18 will.
Divisible by 5. Correct? N plus, which is that? N plus 12. Hope it is clear. So go with the fifth case as well. N is equal to 5q plus 4. Adding 4 on both sides. N plus 4. Nq plus 8. Adding 8 on both sides. 5q plus 12. Not possible. Not possible. N plus 12 on both sides. 5q plus 16. Not possible. N plus 16 on both sides. 5q plus 20. This is possible. All right. This is possible. N plus 16 is only by 5. Hence proved. Hence proved. So we can, what can we conclude here? One and only one out of. Look at this beta. Look at this here. Among all this. Oh, among all this, one and only one is divisible by, which is n. Look at this. What is the question? What is my requirement? Look at this. Show that one and only one out of all this is divisible by 5. That is the question. We shown or not? Look at this. Among all this, only this is divisible by 5. Now check. Among all this, only this guy is divisible by 5. Now among all this, only this guy is divisible by 5. Next, among all this, only this guy is divisible by 5. Among all this, only this guy is divisible by 5. Very simple. Check. Hence proved. Hence proved. Right, guys. So hence you write hence among all this blah 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 given in the question. Hence proved last. You write so here. So hence proved. Sorry. Hope it is clear, beta. So guys, I have to leave as soon as possible now. I'm just, it's been 8:30, sorry, 6:30. So I have another class. Okay, children, if you have any doubts, please come up with your doubts. And I already, today I'm going to upload a worksheet on number system. Sorry, this real numbers. Please go and find a worksheet. I'll be uploading that worksheet in Google Classroom, and I'll be uploading the worksheet of quadratic equations as well. If you are finding a difficulty to get the worksheet from what do you call that, WhatsApp, I'll be uploading in Google Classroom as well. Please do find it out from there and just get it. Okay. Thank you, children. Have a nice day. Goodbye.
Thank you, sir.
Any doubts? Any doubts so far?
The recording will be available, right?
Yes, beta. Yes, beta. Yes.
So,
Please ask me the doubt if you have any doubts. Who is asking for recording?
Sir, I asked.
Yes, sir.
Deepshika.
Please, beta. Tell me any problem. Acha, you missed in
No, it
between
is
for a while.
available, right? Today's recording.
Yeah, you missed in between. Okay, you didn't attend the full session, or you left in
I
between?
came in the last 10 minutes.
You attended only last 10 minutes.
Yes, sir.
Okay, then you must watch recording, definitely. Without fail, you have to watch. Very beautiful session we had, and you have to watch. Very easy and understandable. If at all you find any doubt, beta, you just feel free to come to me and ask. Okay, immediately message me, sir, I am finding a difficulty in that and this. And if at all, if you message me so that I can understand, yes, so and so student facing an issue with that, so I can go with that and just teach you again in the next class. Okay, Deepsika?
Okay, sir.
Thank you. Yes, any doubt, Udbhav, Sai Charan, Pranav?
No doubt, sir.
No doubt, sir.
Nitya, any doubts? Nitya, any doubts?
no doubt, sir.
Great. Okay, let's make a move now. Thank you. Goodbye.
Bye, sir.
Bye.